Hi, my name is Mohamed Handosa and I will talk about the design concept submitted to the AppJam contest by the HoloImage team. Our general motivation is to leverage the HoloLens capabilities in healthcare. The way we approach that is by, first, using HoloLens as an alternative to expensive medical equipment, and second, using HoloLens capabilities to enhance and/or reshape non-healthcare procedures. In order to illustrate the benefits that HoloLens can bring to healthcare, we present four use cases: HoloLens in microsurgery, in augmented surgery, in optometry screening, and in exposure therapy. Our first use case is HoloLens in microsurgery. Almost 4 million cataract surgeries are performed annually in the United States. A surgical microscope is required for inspection, incision, and removal of diseased lens. However, the use of surgical microscope puts surgeon in an uncomfortable position, as you can see in the picture. Using HoloLens as an alternative to the microscope enables operating surgeon as well as assistants to naturally move around an operating field with ease. Additionally, HoloLens screen can be wirelessly shared on a 2D display for learning purposes. HoloLens can serve as a microscope by capturing the real scene via its camera before magnifying and displaying it in a virtual window. It also allows for hands-free zooming in and out using voice commands. Here, we show a comparison between the traditional surgery microscopes and HoloLens as an alternative. In terms of cost, HoloLens provides a cheaper alternative, not to mention that it's a general-purpose device. A traditional microscope requires the surgeon to look through it or look at a 2D projecting screen during surgery. Compared to that, HoloLens is more flexible, as it projects the magnified scene in a window that follows the surgeon's gaze. In the operating field, HoloLens allows surgeons as well as assistants to easily move around compared to the bulky traditional microscope. Adjusting the HoloLens is more convenient compared to the manual adjustment of traditional microscopes. The surgeon can naturally move her head around to look at the scene from different angles. Additionally, HoloLens can provide hands-free zoom in and out through voice commands. We have calculated an initial approximation of the return of investment for our proposed HoloLens microscope app, as well as the return of investment for using the traditional microscope. Calculation results show that the return of investment for investing on HoloLens is much higher compared to investing in a traditional microscope. As shown in the table on the left, the ROI is 300% compared to just 18% as shown on the right. Our second use case is HoloLens in augmented surgery. By augmented surgery, we mean overlaying the patient with a virtual hologram that helps guiding the surgeon to important landmarks. This can be achieved in a set of steps. First, the surgeon works with a 3D model obtained from an MRI or a CT scan. Using a traditional workstation software, the surgeon can add markers to the 3D model. Afterwards, during the surgery, the marked 3D model can be visualized using the HoloLens device and overlaid on the patient to guide the surgeon. Dental implant is one example that can benefit from augmented surgery, where the dentist can mark the drilling position for the implant screw on a 3D model before using this market model for augmenting the surgery during the actual drilling. Our third use case is HoloLens and optometry screening. HoloLens can display a virtual Snellen chart. Its spatial perception capability allows for placing the chart at different room positions. HoloLens can automate eye examination by providing an interactive Snellen chart. The interactive chart can be controlled remotely by the doctor, or it can run autonomously. In order to run autonomously, it can just select random sequence of letters or go through a predefined sequence of letters. In fully automated settings, the optometrist will use a workstation software to select one of a set of predefined letter sequences. Afterwards, the workstation software can take over and inform the HoloLens about the letters one by one. For each letter, the HoloLens will highlight it on the virtual Snellen chart and wait for patient response. The patient needs just to naturally pronounce the recognized letter. At that moment, HoloLens will use voice recognition to get the patient's feedback and then send it to the workstation for comparison, processing, and/or storage purposes. Our last use case is HoloLens and exposure therapy. Exposure therapy is a technique in behavior therapy used to treat anxiety disorders. It involves the exposure of the patient to the feared objects or context without any danger. HoloLens can help providing a controlled environment for exposure therapy with its ability to visualize different holograms of the feared objects in different contexts. Finally, I will talk about our conclusion. HoloLens capabilities including camera, spatial perception, networking, voice recognition, its support for augmented reality and shared holograms, all of this allows for creating innovative applications that can improve the delivery of healthcare. The HoloLens device can act as a multi-purpose medical device. It provides a lower cost alternative to several medical equipment. It can enhance, reshape, and/or simplify non-medical procedures. We believe that there is a promising market for HoloLens healthcare-related applications. Given the time constraints for the contest, we will focus on implementing apps for the following use cases. Use case 1, that is HoloLens in microsurgery, where we will implement the microscope app. Use case 4, which is exposure therapy, and as a proof of concept, we will develop an app that uses a dog as a feared object. Thank you.